Alright, welcome back to Mathematics Lifeline. In today's video, I'm going to do 10 derivatives that progressively get harder as we go. So I did a video just like this with limits recently, and I'm going to try to make this a series on my channel. So please let me know which topic y'all would like to see next. But without further ado, we're going to go ahead and get right into it. Please let me know how you do, and if you have any questions, I'll be glad to answer those in the comments. But we're going to go ahead and get started with level 1. Okay, so for level 1, we're going to have the derivative with respect to x of x squared plus 3x plus 6. Now this is very simple, and most of you could probably do it in your head, but this is just a direct application of the power rule. So let me write that down real quick. So the derivative with respect to x of x to the n, where n is just some number, right? So n is a real number, is going to be n times x to the n minus 1. Or what that means is we bring the n down to the front, we multiply it by x, and then we subtract 1 from the power. So in this case, we have x squared. So x squared, that n is going to be 2. So we're going to pull the 2 down in front, then the x stays there, and then we just subtract 1 off of that power. Well, 2 minus 1 is just 1, and x to the first is just x. So we don't even need to write that part. So the derivative of x squared is 2x. Now with the 3x, this is really 3x to the first power. So we can use this power rule just the same. So we'll pull the power down, which is just 1, and we multiply that by the 3. So 3 times 1 is still 3. And then we'll subtract 1 from the power, which is x to the 0, and x to the 0 is also 1. So 2x plus 3 is what we have here. And then this plus 6, we need to think about that one because the plus 6 is just a number. It's just a constant. And when we take the derivative of a constant, it is always 0. So we don't even need to add anything, and this 2x plus 3 is our final answer. So let's go ahead and move on to level 2. Alright, so here we have level 2. This is the derivative of sine x plus ln x minus e to the x plus cosine of x. Now, this is a really long function, right? There's 4 terms we need to differentiate, but none of these are complicated. And the reason why is because these are all ones that we should know just off the bat. These should come right to our minds immediately because we use these functions all the time. So we have some trig functions, we have some logarithm functions, and an exponential function. So we just need to know these ones. So we can start with the sine x. So the derivative of sine x. Well, by definition, how we define it, it's going to be cosine x. So that's the derivative of sine x. Now ln x, what we always do is 1 over the input, and if you're doing chain rule, you'll need to add a little bit more, but in the case where it's just an x on the inside, it's just 1 over x. That's the derivative of natural log x. E to the x stays the same no matter what, so this is going to be a minus e to the x. And now the derivative of cosine x is negative sine x. So because it's a negative sine x, this sign needs to change. So we're actually going to have a minus sine x. And that's it. That's the derivative right here. And all we used was just our memory, essentially, to figure these out because these are just ones that you definitely need to know when you're doing your derivatives. But yeah, that's it for level 2. We can go ahead and move on to level 3. All right, so here's level 3. This one is the derivative of 3x times cosine x. Now this is the first time where we're actually going to need to use a rule, and this one is going to be the product rule. So let me write that down for you for reference. So the derivative of f of x multiplied by g of x is equal to f of x g prime of x plus g of x f prime of x. So you can actually flip these orders, and some people do, but I usually keep it in this order. But that is the definition of the product rule. So we're going to use this to take our derivative right here. So we're going to call this 3x, we're going to call that f of x, and then this cosine x is going to be g of x, right? So just to keep it consistent with the form, because these are two functions being multiplied, right? We can't really do anything as the same function here because they are two separate ones. We have two functions that involve x, so we definitely need to use the product rule here. So with the product rule, we have f of x is the first one that we put in, so that's just a 3x. So we'll put the 3x there, and we're going to multiply that by the derivative of g of x, right? So the derivative of cosine, even from the last question, we know that's going to be a minus sine x. And then we add We add g of x, which in our case is cosine x, and then we multiply it by the derivative of f of x. Now the derivative of 3x, again from the first question, we know that is 3. So we've taken our derivative here, so now the only thing we can do is just write it in a little bit nicer form. So I'm going to come down here, and I'm going to say this is a minus 3x sine x plus 3 cosine x. And that is the simplified version of that derivative, and that will be our answer for level 3. Okay, so we can go ahead and move on to level 4. Okay, so here we have level 4. This is the derivative of sine x over cosine x. Now there's two ways we can do this, and I'll show both ways for this solution. But we're going to try using the quotient rule first, right? We're going to try to use a rule here because we have a function over another function, which means we should probably use the quotient rule. So let me go ahead and write that one down for you. So that one says the derivative with respect to x of f of x over g of x is equal to g of x f prime of x minus f of x g prime of x all over g of x squared. So it's kind of a long rule here, but you get to know this one and you remember it pretty quickly. But that is the statement of the quotient rule right there. So we're going to try to take the derivative of sine x over cosine x using this quotient rule. So just like the last time, sine x is going to be f of x, cosine x is going to be our g of x. So when we do this, we know that the first step is going to be to leave g of x alone. So in the numerator, we're going to have cosine of x, and we're going to multiply that by the derivative of sine x. And the derivative of sine x is cosine x. So that's what we have right there. And then we're going to subtract off f of x times g prime of x. So f of x was sine x, and then g prime of x is the derivative of cosine x, and the derivative of cosine x is a negative sine x. So we'll have minus sine x right here. And then we divide all of that by the bottom squared, right? So cosine of x squared, so we'll write that as cosine squared of x. Okay, so now we want to try to simplify some stuff. So when we have cosine x times cosine x, that's going to end up being cosine squared of x. Now in this side, we have a minus sine x times a minus sine x. So that ends up being a plus sine squared of x. And all of that is over cosine squared of x. And we're not done here because in the numerator, we can simplify this down a whole lot. Because remember the Pythagorean identities? That says that sine squared plus cosine squared is always equal to 1. So it doesn't matter that we have cosine squared plus sine squared because addition is commutative. So this numerator can simplify down to 1. And then the denominator is still cosine squared of x. But we can make this just a little bit nicer because remember that 1 over cosine x is secant x. So 1 over cosine squared of x is going to be secant squared of x. And that will be our final answer for this derivative. Now, like I said, there's another way we can approach this question. So I'm going to erase this quotient rule down here, and I'm going to show you another way that we can approach this. So if we have the derivative of sine x over cosine x, well, remember that sine x over cosine x is equal to tangent x. So we can actually rewrite this derivative as the derivative with respect to x of tangent x. And now this one is just one that we should definitely remember, right? So the derivative of our trig functions we should know by heart, and this one is secant squared of x. And of course, that is what we got by doing it with the quotient rule. Doesn't matter which way you like to do it, but you can see that this one is much quicker if you notice that sine x over cosine x is tangent x. Okay, so that's it for level 4. We're going to go ahead and move on to level 5. Okay, so here we have level 5. This is the derivative of sine squared of 3x. Now, this one's going to be our first application of the chain rule. So again, I always like to write these rules down for you. So this one is the derivative with respect to x of f of g of x. So this is a composition of functions, right? This is always equal to f prime of g of x times g prime of x. So basically we take the derivative of the outside and then we leave the inside alone, and then we multiply by the derivative of the inside. Now, with this one, we're actually going to have to do it 2 times. So this chain rule is a little bit tricky here. But the way we're going to do this is we're going to rewrite this derivative. And I always like to do this when we have a sine squared. I'm going to write it as sine of 3x all squared. And the reason is because now it kind of looks like a power rule, right? So we're able to do this directly. A lot of times students will confuse the sine squared, so it's helpful to write it like this. Either way is fine, but I think it's more helpful to write it that way. Okay, so when we take the derivative of this, the first thing we're going to do is we're going to start on the very far outside of this function. And the very far outside is this power of 2 that we have up here. So we're actually going to pull that 2 down in front. And then when we do, we're going to leave everything else alone. So sine of 3x, we're going to leave it alone. And then we need to subtract 1 from the power, right? This is just the power rule. But when we subtract 1 from 2, we just get 1. So we don't even need to write it. Okay, so that's the first step of our chain rule. But now the next step is we need to multiply by the derivative of the inside. But the inside itself is a chain rule, right? So we're going to start with this sine function. So we're going to multiply by cosine of 3x, right? Because we leave the inside alone now. But then we need to multiply again by the derivative of the inside, and the derivative of the inside is 3x. So the derivative of 3x is equal to 3. Okay, so now we can just go straight from here to the simplified answer. We've taken our derivative, we've kind of done the chain rule a few times, so we'll just simplify. So this is really just going to be a 6 sine of 3x times cosine of 3x. And that's pretty much as simple as that answer is going to get. Because all we're doing here is really just multiplying this 3 and 2, and we're getting sine of 3x times cosine of 3x. So yeah, that's it for level 5. Let's go ahead and move on to level 6. Okay, so here we have level 6. This one is the derivative of the natural log of x squared minus sine of 2x. Now again, this is another application of the chain rule. I'm not going to write it again, but this is another chain rule. So we're just going to take it piece by piece. So remember when we take the derivative of the natural log, we're going to do 1 over the inside. So we're automatically going to have a 1 over x squared. And then we multiply, because of the chain rule, the derivative of the inside. So the derivative of x squared is equal to 2x. Right? We know that from the first level had that actually. So we know that derivative is 2x just by the power rule. So we're done with this one. Now we need to worry about the minus sine of 2x. So we're going to subtract off. Now remember, with the chain rule, we take the derivative of the outside. So the derivative of sine is going to be cosine. And then we leave the inside alone. And then we're going to multiply by the derivative of the inside. And the derivative of 2x is equal to 2. So from here, we're just going to try to simplify some stuff. So this is equal to, it'll be 2x over x squared minus 2 cosine of 2x. And now there's one more thing we can do. We can simplify this term right here because we have 1 copy of x in the numerator and 2 in the denominator. So we can actually cancel out this one with one of the ones down here. So this is really going to give us 2 over x minus 2 cosine x. Or I'm sorry, cosine 2x. And that will be our answer for level 6. So it's really not that hard. The problem is remembering to do the chain rule. A lot of students will forget and they'll just put 1 over x squared, or they'll just put cosine of 2x, right? But it's really important that we multiply by that other factor. So that's the end of level 6. We'll go ahead and move on to level 7. Okay, so here we have the derivative of tangent inverse of cosine x. So this is our level 7 question. And if you're very good at inverse tangent or very good at your inverse trig derivatives, you're going to think that this is rated too high. However, a lot of students, including myself, never got taught inverse tangent in their classes, especially the derivatives of it. So I never learned inverse trig derivatives, so I think it's very important that we know these, and they are pretty hard to memorize. So for this case, we're going to need to use the chain rule with it, but I'm going to go ahead and remind you of the derivative of inverse tangent. So if we have the derivative with respect to x of inverse tangent of x, this is equal to 1 over 1 plus x squared. So that's the basic derivative of it. So we do 1 over 1 plus the input squared. Okay, so we're going to do the same thing here. So now our inverse tangent is the outside function. So we need to start with that. So we're going to take 1 over 1 plus. Now the input squared is going to be cosine squared of x, right? Because we're just squaring what's on the inside. Now, this is where we need the chain rule because we didn't have just an x in here. We had a cosine x. So we need to multiply by the derivative of this cosine x. And the derivative of cosine x is minus sine x. So when we write this in the most simple form, we're going to have negative sine x over 1 plus cosine squared of x. And that will be our final answer for level 7. Now, like I said, this is not that hard of a question. It's just one version of the chain rule, but a lot of people forget this or were never even taught this. So it's very important to go over it. And yeah, so that's it for level 7. We'll go ahead and move on to level 8. Okay, so here we have level 8. This is the first one that's going to be a little bit different. So it says we want to find dy dx if our function that we have is 3x squared plus xy plus 3y squared equals 19. Now here's why this one is trickier, because we need to use what's called implicit differentiation. So because we're taking this derivative with respect to x, every time we take a derivative of y, we need to multiply by a dy dx to signify that we took a derivative of y, right? Because technically we're not allowed to do that unless we add dy dx, because we're only taking the derivative with respect to x, so we don't know what y is. So when we do this, we're going to need to take the derivative of both sides. So what we're going to do is we're going to take the derivative of the left and the right. Now, the easiest one to do here is going to be to take the derivative of the right side. So I'm actually going to move down here. The derivative of the right side is going to be equal to 0. So whatever we get, it's going to be equal to 0, right? Because 19 is just a number. So now we want to take the derivative of our left side. So this 3x squared term, we're going to start with that. Now, this one is just standard practice of the power rule. We're going to pull the 2 down. So 2 times 3 is 6. So we'll have 6x to the 2 minus 1, which is just to the first power. So that one's pretty standard. No tricks with that one. Now this xy. So I'm going to put a bracket here to signify that this is its own thing. Now xy, because we're taking derivatives with respect to y now, this is actually a product rule. So we're going to use the product rule here, but the difference is when we take a derivative of y, we need to multiply by dy dx. So remember, the product rule says we take the first function, so it's just x, and we multiply by the derivative of the second. Well, the derivative of y, we treat it as x originally, so the derivative of x would be 1, and the derivative of y is 1, so it's going to be 1 times dy dx, because we took that derivative of y. So it's very important that we multiply by dy dx. And then, of course, the other part of the power or the product rule, we need to add y, right? In this case, y is our second function times the derivative of the first. Well, the derivative of x is just 1. So we're just multiplying by 1. We don't even need it. So really, we don't even need this 1 right here. So that's the product rule that we did right there. So that's why that one is a little bit tricky, because a lot of people don't see that as a product. But it is, so it's very important that we do that. So that's the xy term. Now we need to worry about the 3y squared. Well, the 3y squared, we're going to treat it the same way as this 3x squared. So it's going to be plus, it'll end up being 6y, but we took a derivative of y, so we need to make sure we multiply by dy dx. Okay. So kind of a lot of work there, but now it's just down to simplifying and solving for dy dx. So what we're going to do is we are going to multiply everything out and simplify what we can. So we're going to have 6x plus x dy dx plus y, right, because we're just adding 1 there, and then plus 6y dy dx is equal to 0. Okay, so now we want to solve for dy dx. So what we need to do is we need to get all the dy dx's on one side and all of the other terms on another side. So we're actually going to subtract off the 6x and the y. So what we're going to have is x dy dx plus 6y dy dx is going to be equal to negative 6x minus y, because we're subtracting those over. All right, we're subtracting the minus 6x over to this side and subtracting the y over to this side. So that's where we're getting this. Okay, so now to solve for dy dx, what we need to do is we're going to factor it out of these two terms. So if we factor a dy dx out, so we take dy dx, and we'll have left over x plus 6y, right? X plus 6y. That's the factored version. And the reason we're doing this is so we only have one dy dx to worry about. And of course, this is still equal to minus 6x minus y. And then the final step to solve for dy dx is we're able to just divide this whole term over here. So that means dy dx is going to be equal to minus 6x minus y over this function right here. So it's x plus 6y. And that is our solution for dy dx. So this process is called implicit differentiation. If this is the first time you're seeing this, I know this is a pretty tricky example, but that is why it's level 8. So yeah, this is implicit differentiation, and this is going to be important to know for the next problem as well. We'll need to use it a little bit. But yeah, that's it for level 8. We'll go ahead and move on to level 9. All right, so here we have level 9. So we're going to have the derivative with respect to x of 4 to the x power. Now, it's very important to note that we can't just do the power rule here, right? And a lot of students will try, but we're actually not able to because x is a variable, right? So x can change. So we can't just pull the x down because we don't know what x is. So in this case, we need to use what's called logarithmic differentiation. So the way we do these problems is we're going to set up a function. So we're going to say that y is equal to 4 to the x. And we're going to need to take the derivative of both of these sides, but we're going to do it in just a second because we want to get this x out of the exponent. Because the problem with taking the derivative of this directly is that the x is up there as a power instead of just being multiplied, right? So we want to find a way to get the x down. And the easiest way to do that is going to be to take the natural log of both sides of this function. So we're going to have the natural log of y is equal to the natural log of 4 to the x. And the reason we do that is because using natural log properties, we're actually able to pull this x down in front. So we'll really have the natural log of y is equal to x times the natural log of 4. Right? We're allowed to do that. That is a that's an exponent rule for logarithms. So from here, we're going to take the derivative of both sides. So we want to take the derivative of the natural log of y. So remember, when we take the derivative of a natural log of something, we do 1 over the input, right? So 1 over y times the derivative of the input, which in this case is going to just be dy dx, right? This is implicit because we're taking the derivative with respect to x, and we have a y. So we want to make sure we multiply by dy dx. Okay, so that's the left side taken care of. Now we want to take the derivative of the right side. So we have x times ln 4. Now, some students think to do the product rule here, but we don't even need it, right? So maybe it'll help if we write it like this. This is the same as natural log of 4 multiplied by x. So this is just a standard power rule because ln 4 is just a number, right? So this is the same like if we took the derivative of 2x, of course it's just equal to the number, right? It's just equal to 2. So in this case, it's going to be the same thing. It's just equal to that number in front of the x. So that means that the derivative of the right side is just equal to the natural log of 4. So now we've taken the derivative. Now we want to solve for that dy dx in order to get our answer. So the way to do that is we're going to need to multiply both sides by a y. So we're going to multiply by y over here, so multiply by y, and multiply by y over here. So then what we'll have is dy dx is equal to ln of 4 multiplied by y. Now, we're not done because remember we set up this function to be y equals 4 to the x, right? So if y was equal to 4 to the x, that means we can plug this right back in for y. So this is equal to ln of 4 multiplied by what our function for y was, which was 4 to the x. And that right there is our final derivative. So logarithmic differentiation can be pretty tough. There actually is a general rule for these derivatives, and I want to show that to you. So the derivative with respect to x of some number to the x power is always equal to the natural log of the number multiplied by the function that we started with, right? So it looks similar to the power rule in terms of this part, but the x and the n are flipped here. But you could see that this actually works because we had 4 to the x. So n was 4. So that means we would have ln of 4 times 4 to the x. And that's exactly what we have. So that's the general form of these right here. So some professors will let you use this, but others will have you go through this whole process. So I think it's important to do it just to see, how it's actually derived. Okay, so that's it for level 9. We're going to move on to level 10. This one is going to be a little bit different and it's going to be a little tricky, but it is level 10 for that reason. So we'll go ahead and get started with that right now. Okay, so here we have level 10. Now I'm sure you're looking at this and you're thinking, well, this looks nothing like a derivative. But it actually is. This is the definition of a derivative. So this is the definition of the derivative of sine x, right? And of course, we know what the derivative of sine x is, but do we know how to do it with the actual definition? So that's what we're going to try to do for level 10 here. Now, this is a pretty tricky question. You need to know a few things. There's a few things that we have to kind of take for granted here, too, just because of the scope of this video. But yeah, we're going to go ahead and go through this. So if you want to try it, feel free, but I will do it right now for the video. Okay, so here's what we're going to do. We need to find a way to expand this sine of x plus h. Now, we need to remember, this is a trig identity. We have sine of a plus b is equal to sine a cosine b plus sine b cosine a. This is like the sum of angles in a sine function, right? This is how we can express them. So we're going to try to do that with this one right here. So we're going to rewrite it as the limit as h goes to 0. Now, this is x is our a and h is our b here. So what we really have is sine x cosine h, right? That's this first part, plus sine h cosine x. So that's how we've expanded this a little bit, and now we still have this minus sine x. And then, of course, all of it is over this h. Okay, so what we're going to do now is it's a little, you kind of have to pull it. It's hard to do. It's hard to do. It's hard to see what to do here. But what we need to do is we're going to pull out a sine x term from two of these factors, right? So what we're going to do is we're going to say we have the limit as h goes to 0 of. So what we're going to have is sine x, and we're going to multiply that by cosine h minus 1, right? We're factoring sine x out of this term and out of this term. So we have cosine of h minus 1. So we're taking sine x out of this one right here, and we're taking sine x out of this one. There is no sine x here, so we can't take anything out. And we're going to set that all over h. And then we're going to split up the fraction. And the reason we're allowed to do this is because h is the only thing in the denominator. So because of that, we're able to just say, well, what's left over here is this sine h cosine x all over h, right? This is okay because if we were to add these fractions, we would get the same thing. So we're going to split the fractions up. And then we need to remember that the sum of two things in a limit, you can actually break the limit up. So it's going to be the sum of limits. So we can actually rewrite this as the limit as h goes to 0 of sine x times cosine h minus 1 over h plus the limit as h goes to 0 of sine h cosine x all over h. This is the same thing. We're allowed to do this. This is the limit law. Okay, so now here is where this gets a little bit tricky. So we're going to look at these terms individually. So when we have the limit as h goes to 0 of sine x times cosine h minus 1 over h. Now notice that sine x, we have nothing in this limit that depends on x. Everything depends on h. So sine x in this case is just going to be a number, right? Sine x is always outputs a number. So we're allowed to pull this out front of the limit. So what we have is sine x multiplied by the limit as h goes to 0. Then we'll just have cosine h minus 1 over h. And we're going to do the same thing with the second one. So the second one, notice that it's only dependent on h again. And that cosine x, again, is just going to be a number. So we're allowed to pull the cosine x out front. So plus cosine x multiplied by the limit as h goes to 0 of, this will be sine h over h. Okay, so this is where I'm talking about we have to kind of take this for granted. And the reason is because this limit right here and this limit right here are both limits that we kind of take for granted, especially when we're taking Calc 1. Because this limit right here, we can prove it geometrically, but I'm not going to in this video. This limit actually evaluates to 0. And sine h over h, as h goes to 0, this one you actually might learn when you're doing limits. We actually use this to define the derivative of sine and cosine. That's why I'm not really able to do anything else with this for this video. But this one is actually defined as 1. Now again, like I said, these can be proven, but we're just going to have to take it for granted today. So what we end up having is sine x multiplied by 0 plus cosine x multiplied by 1. And you can see this is nice because this term will just go away, and we just have cosine x times 1, which of course is cosine x, which is exactly what we were looking for. We took the derivative. This is the definition of derivative of sine x, and we knew we were looking for cosine x, and that's what we ended up getting. So that's great news, and this is our level 10 derivative. Now this one, I agree, is tough, and it bothers me that we can't go through these, but just, for Calc 1 students, it's probably too much to go through how those are actually presented. But yeah, this is the definition of derivative for sine x. This is level 10, and we have completed all 10 levels of derivatives. So like I said, feel free to let me know in the comments how you did. If you have any suggestions for future videos like these, I really like these videos, just kind of progressing through these concepts. So if you have any other concepts you'd like me to do 10 levels of, or any recommendations, I would be glad to take those. But if not, then thank you for watching, and I will see you next time.